Hi everyone, nice to see you here. I'm going to talk a bit about some recent additions to the Go standard library. As you may know, Go 124 was released not quite recently, it's almost, I think, like 2 months ago by now. So who's using it in production already? Yeah, most of you. So it's probably a bit boring for you, but I hope you can still take away some new things as well. My name is Thomas. I'm a first-time speaker here. This is why you got to see this slide. I'm part of a small company in Bern called Taktumotum. We're a bunch of freelancers that basically help you with IT projects. I'm in the IT space for more than 10 years, writing Go code for more than 8 years by now in professional environments. You can also talk to me about things like 3D printing, espresso, home automation, stuff like that. So in case you want to know something else, I will be around after the talks. So, Go 124. It was, as I said, released almost 2 months ago. A bunch of people are already using it. And as always, there are some great new additions to the language. Also in this release, there was a minor release and another one yesterday, not a joke, actually. It really was released on 1st of April with a bunch of security fixes. So, new things, right? The first new feature in Go 124 is tool dependency tracking. And this one, honestly, in my opinion, is one of the greatest additions in the recent times. Basically, there's a new directive in the Go module. It's called tool, and it tracks your tool dependencies. And if you have a look, like in the past, for example, I have a small program. It has a IOTA defined with all of my hobbies. And obviously, if I want to print them, let's just get them away. So if I want to print them, I want to print a string representation of them, right? Not just a number. So in that case, I use a tool from the X package called stringer that basically takes my hobby IOTA and generates the strings for every hobby. So you can see I'm using Go generate, that basically then triggers Go run and calls the stringer, calls into the stringer code. But if someone else starts to develop on this software as well, obviously he needs to use the same version of the stringer tool, right? Because there could be like differences between different versions of the stringer tool. So I have to keep track of this dependency somehow. In old versions of Go, there was a trick. Usually you could see this by, there was a tools.go file in most of the repos. There was like an empty import and a special build tag in there to basically trick Go into adding it to your Go module. And then you see, okay, we have the X tools package is now tracked by my Go module and thus ensure that everyone is using the same version of stringer. Now with the tool dependency tracking in Go 124, it's much, much simpler. There's just this tool directive. You can enter the path to the module of the tool you're using, and to generate, you can simply use Go tool, stringer, and provide all the arguments to it. That's it. Pretty neat integration. There's also, it integrates with GoGet as well. So there's a flag called -tool. So if you want to add a dependency, you can simply go get it as well as with every other dependency, basically. So pretty cool. Especially if we come back to Michael's talk, I guess lots of you also use protobuf, so you have to generate all the protobuf file code in Go. And usually this is where you see like all these generate statements splattered over the code. A bunch of people have to use the generator, so this really helps in that regard. Pretty cool feature. Then there's generic type aliases. I don't know, there are people from Google here, they probably use this, but most of you probably not. So I don't know if it's that useful, to be honest. But basically you can define like a generic type alias now. In this case, it's just a map of bools, and you can see how I can use it down here. And basically the type is then a map string bool. No example here, nothing special in my opinion, but yeah, still part of the recent release. So this one actually is way more interesting in my opinion. Sync test run. I prepared a small example for this as well, synthetic time. So given a code example like this, so some function that is reading from a channel that has a hard-coded timeout, so if nothing comes in from the channel, after 10 seconds we return an error. And now in my tests, I probably want to test the timeout cases as well. But in this case, this means my test is running for at least 10 seconds, which is super boring or super annoying if you're used to using Go tests and its feedback is almost immediately. But if you have to deal with these kind of things, it gets annoying pretty fast. And this is where sync test comes in handy. Basically, you can wrap the test now, the test function in this sync test run function. And what happens under the hood is basically once every Go routine that's running inside this sync test run function is blocked, the time automatically advances. So in this case, the read call will block. It's the only Go routine that's running in this code, basically, and then the time will automatically advance and unblock the timeout case in here. So the time after case will be unblocked. There is a little caveat here. It's experimental. So in order for it to work, you need to set this environment variable. I don't know if it will land in Go 125. But for now, yeah, as I said, it's experimental. Pretty cool thing. Then there's weak pointers. So yeah, basically what the slide says, you can now take a weak pointer from a regular pointer and you can get the value using the value method of this weak pointer. And I was actually, I struggled a bit to find like a useful but simple enough example for this, but I ended up writing this here. So there's a blob type, it's basically a slice of byte. Some function to generate a blob, which actually has a bit of a size. And then I wrote like a cache. So there's basically a string which you can use to identify a bunch of blobs. And the cache only holds a weak pointer to the actual blob. So you can see there's a bit of initialization happening. You can set a value. You can get a value. And you see it uses the new value method from the weak pointer. You can get the length of the cache. You can get the keys from the cache. So basically, everything's there that you need for a cache. But what we do here, we create the blob. We set it in the cache using the key myblob. We print the value before we run the garbage collector. We make sure there's no strong reference to the blob anymore, and then we trigger the garbage collector. Right. What happens here? Yeah, it's likely nil. It's not guaranteed to be nil, but after garbage collection, it could be nil. The thing is, these two lines. Can you guess what they print? Yeah. The thing is, the weak pointer is now gone. It was reclaimed by the garbage collector, but you can see the map key is still there, right? Just the value behind set key is no longer existing. So actually the len will still return the length of the map, which still has the keys, and the keys function obviously will still return the keys of the map, in that case, myblob. But to solve this, there's another cool addition to the language, which is improved finalizers. I know that Tom, for example, had to deal with the old API. It's the runtime set finalizer thing. This existed, I don't know for how long by now. But this one was notoriously hard to use. It was super hard to get right. And basically, what it did, it's the same as runtime add cleanup. Whenever a value is, or something is garbage collected, this function is executed, and you can basically clean up, add some additional cleanup logic. And now with runtime add cleanup, it's much more convenient to do so. There's an example here as well. which we can use in this cache case, basically to clean up the map after the weak pointer was reclaimed by the garbage collector. But there's a small issue here, and Tom is laughing, I know why. Yeah, I mean, the comment is a hint. So this function, this add cleanup function in here, is not guaranteed to run immediately. This is basically the first hint. So it runs in a separate Go routine. It's also written in the docs, actually pretty prominent, that everything that you add in this cleanup function is run in a different Go routine. So in that case, I'm now accessing my map from two different Go routines, basically, concurrently. So there's a race condition in here, in theory. In practice, for this example, it doesn't really matter, but it is there. There's also an example where I added a bunch of mutexes to work around this, but yeah, you get the point. So then another thing related to maps. Maps now use Swiss tables behind the scenes. So basically, Go changed the underlying implementation of maps. They claim that it's 60% faster in some cases, and in some edge cases, performance regressed compared to Go 123. I didn't know what to add here. I'm not super familiar with the Swiss tables algorithm. There's a bunch of links at the end of the slides. You can read up on this if you want. There's even a blog post on the go.dev website if you want to know more about this. And yeah, so I just came up, or like an AI came up with this, but I don't think it's a super good image anyway. Pretty cool thing as well. I guess everyone that had to serialize, for example, dates or a time to JSON, that somehow ended up with this basically. So zero value of a time is, you can see it down here. So it's, let's say, some arbitrary date is the zero value of a time. And even if you use the omit empty tag on your JSON, or the omit empty flag on your JSON tag, the date still gets serialized to JSON. And now there is the omit zero JSON tag, which can basically alter this behavior as well. The cool thing about omit zero is it's customizable. So if you have like your own type, you include your own type by a pointer in here, and this type implements the isZero method, then omit zero, the tag will also work for your custom type. It's pretty cool. And yeah, as I said, you can see the output below. Then directory scoped file system access, also a pretty cool thing, especially if, I guess, more or less everyone had to do something like that in the past. So whenever you deal with user input and files, so for example, you have like the photo boot and you want to serve files or the photos that were taken before from the file system, you need to make sure that your web server only serves the photos that were taken and not like some arbitrary files like etc shadow or something like that, in case of like directory traversal attacks. And this thing actually does everything for you. So you just provide a root directory to it, and it will only allow you to go down on this root directory and not back up again. Pretty neat as well. Yeah, I've prepared an example as well, but I will keep it short today. You get the point, I think. There's more, as always. Actually, a lot more. So a bunch of things to mention. SyncMap has also changed the underlying implementation. It should improve performance as well. I think there are some numbers on the Go release notes as well. Testing the benchmark loop, actually also pretty cool thing. It's much less error prone now. I don't know if you've used the old APIs, but you had to deal with resetting timers, stuff like that. So this is also a cool addition now. Test context as well. Whenever you have to use a context in tests, you can now use the context method from the testing t-type. There's a bunch of new interfaces for appending stuff, text appender, binary appender, whatever. And also new iterators in the strings package. Actually, yeah, I only linked to the strings package, but yeah. Whoops. And SHA-3 support was also added along with some other cryptography things. And for the people that use CGO, there are some new annotations that can improve runtime performance. I don't know if somebody's even using CGO or these kind of annotations, but there are basically 2 new hints to tell the Go compiler that this function will not escape or will not call back into other Go code. So it just helps the compiler to optimize your code more if you use these annotations. And yeah, there's even more. So I included a bunch of links, of course. The documentation on the Go blog is always a good read, a very good read. There's also the blog to the Swiss table implementation for maps, also pretty good read. I read it on the train from Bern to here. It's interesting, but I think I'm not qualified enough to tell how it works, so read it on yourself. And yeah, I will include the link to the slides in the comments of the meetup. That's it. Thanks a lot.